and then that kind of helps create a lot of contrast and a pretty like striking image. So it's not like some of these with more colors I wasn't a big fan of, but like these here with just like two-tone kind of color scheme was a pretty big inspiration as well for me. So we'll get started now with Houdini, just like a basic scene, and kind of going to be going over instancing like the workflow, kind of the tools that are needed to make what I did, and then at the end of the stream we'll be actually going through one of the files. All right, so if we make a geometry node, this is just like how we're going to get to editing geometry, like editing a mesh. So at the object level, this is like where you construct the scene, you have a camera, lights, all that stuff, and then when you go inside of one of these geometry containers, then you can actually like move points around, edit vertices, do all kinds of fun stuff like that. So if I just make a file node, this is going to load this box, just says XYZ on it. Another thing we can do is if we change this file path here, we go, instead of just default.bgo, we could go to defaccess.bgo. So you can see here, now we're actually getting like a XYZ axis or gnomon, kind of like what's at the corner of the screen. So this is what I'm going to use, just setting up this instancing and kind of explaining the coordinate systems and how that kind of works. It's just a simple kind of shape or representation to get started with. The reason this works, or that I knew how to do that, is that if you go into your file picker, instead of this environment variable that means like relative to your Houdini file, they have another environment variable that's $HFS. So that's, I think it stands for the Houdini file system. And when I press enter, that kind of takes me, if I expand this is like where you've installed Houdini on your operating system. So if I go into the Houdini and Geo directory, this file will automatically search this directory whenever you just put in a path. There's like a list of 8, I don't know, like 4 or 5 different places that you could add to it if you really want to customize things, where this will search for geometry or files before you even give it the full path. So another example here at the bottom, they have some shader box, shader teapot. So if I pull that in, now you can see it's doing the full path to it, but if I eliminate that extra stuff, it still knows where to grab that geometry from. So I have a few different things to get started with now. You can see this axis, it's a little bit too small. So if I get a transform here, then I can just make that bigger. So if I look at my template geometry, or if I middle mouse button here, then I can see that my min and max, the bounding box size of my geometry is around like 1 unit. So before it was just like 0.1 unit or 0.12 units, so it's a little bit too small. So that's the reason why I scale it and make it a little bit bigger. Get it close to 1, so it's like a unit size. If you're working with like 0.01 or 25 or just like arbitrary numbers, it's not really good practice, just because like if you just keep it close to 1, then it's more of like an expected size or an expected scale that you'll be working with. So the next thing that I was doing was just scattering points and using a grid just to set things up like that. So we start with a grid or just any kind of geometry, and then the scatter node will randomly distribute points on it. It has a few settings here that are useful, this relax iterations. So without it, this is just like a pure kind of white noise randomness. And if we turn that on, then it will do this like Poisson relax algorithm. So the more iterations that you run on that, the more that it will kind of like try to evenly separate these or spread them out. And then if I use this copy to points node, we get, we want the points into this input and then the geometry into this one. So now we see all of these axes that I've copied onto my points. They're either like too big or it's just too many of them. So one of the things that I can do is make an attribute. This is like extra information that gets added to the geometry. And there's certain ones that Houdini looks for or recognizes for how this copy to points node or any copying or instancing inside of Houdini works. So if I make p-scale and have it at 0, you can see everything disappears. So if I set this to 0.1, now you can see that this is influencing the scale of all of these when they get copied onto the points. So the default, or before I had this p-scale attribute, it was just always using the uniform scale, which was 1, or the unit scale. But if I set this to 0.1, then we can see I'm getting like 1/10 of the scale. So the place, or the way that I know kind of how that works is if I look at the Houdini help page. So we'll get that over here. This is the copying and instancing point attributes. Then you can see this useful kind of like list or table of all the attributes that you can add to the geometry to control how the instancing or copying works. There's some priorities overall. This kind of gets a little bit long-winded and stuff like that, but this is a very useful place to go to kind of refer to the attributes needed, or the attributes that Houdini will look for when you're copying and instancing things. And then if you're starting to use a lot of attributes, I'm using this desktop right now, but I like to get a geometry spreadsheet open, and then I can see my p-scale for all the geometry. So I'm not always kind of like scrolling through this entire thing like a Excel spreadsheet or something, but just to see which attributes exist and get an idea of what number they're set to. It's a pretty good thing to use. It's more of like a technical debugging thing. You don't always have to have it up, but I like to keep it down here just to refer to it when I need it. So that's how you can set the p-scale, or just the uniform scale of things. But if we look at those renders, they're not always like uniform scales. Let me see if I can get some of these pictures back up. So this is just going through my renders again. So if we look at this one, you can see that these aren't always the same scale overall, like the uniform scale is changing, but then also one of the things that I was doing was when they're getting like shorter, they're still pretty wide, so they don't completely disappear. So I'm just changing the height, but I'm not necessarily always changing like the width or the other dimensions of it. So if we want to be able to control the instancing a little bit more, have more control over it, or a little bit more granularity over our control, there's a scale attribute. So this one, the size of it is like 3. So you can see when I'm changing this, it's the number of components. And then if I really wanted to, up here, I could change this to vector, and then that changes it to X, Y, Z, like a coordinate, or just a direction vector or a scale vector or whatever. In this case, this is a scale vector. So each component of this changes the scale of the geometry just in that direction or that component. So if I want to make everything short but still kind of wide, then I can influence it with this scale attribute. If I wanted to make everything thin but still pretty tall, I can do it that way. And then some more advanced kind of things with this copying node is that usually this Z direction will point in the direction of the normals on the geometry. So right now I don't have any. It just kind of guesses when I look at them. But if I wanted to add normals to my geometry, then you can see I'll add them to the points. So now this is, we have normals, we have positions, we have the uniform scale, and then we have the kind of directional scale. And then the last thing that I'll make is the up vector. So again, this is a size 3. And then this one will influence which direction is up for the geometry. So usually the z-axis will point in the normal direction, and then the y-axis will point in the up direction. I think I messed up something here. Okay, so my normal right now when I'm trying to add it, it's just looking at points and it's not an actual grid. So I'm going to shake that out and move it up, bring it up to my source geometry, and now you can see it's actually adding a normal vector. So it's just kind of messed something up there that was throwing me off. So having the normal now, you can see that the z-axis is looking along the normal direction, and then the up vector will be what direction the y is looking down. So if I change this to 1, then you could see it's going in the positive x direction. So this is the x component, blah, blah, blah. If I go back here, then we're looking down the z component. So you can see here, this is the positive z direction, and now my y-axis is pointing in the positive z direction. So if I don't want to set the up direction manually, if this attribute randomize, you'd see by default this will just edit the color or assign the color of the geometry random values for each point. So this attribute randomize is a pretty useful node to just give me random numbers for each point or each element that it's processing. If I change it from color to up, now you can see that each of these are getting like random kind of rotations. But because I'm using the normal that's been assigned up here and also the up, the normal takes priority and it's still telling z to be the up direction, or like 0, 1, 0, or just straight up. And then this random up direction is influencing the y, so that will just spin things around the top kind of randomly. And then it's usually a good idea, instead of uniform continuous, to do direction or orientation. So that will just tell it it's making a direction vector. If you do this uniform continuous, it's kind of thinking like a color, so it's not giving me any negative numbers. You can see that everything's like pointed in a general direction. But if I do this, now everything is like 0 to 360 degrees randomly rotated. So that's how I can do completely random rotations. If I get rid of that, or I don't add it, and if I don't even add an up, then you can see everything's just getting like this uniform direction. So this is a pretty good tool to use, or way to control the orientation of copies, especially when we want to create those landscapes. We want to have a lot of control over how things are rotated. It's going to influence like a lot of the final image. So we could also use this attribute VOP. So this is kind of like a shader, but it runs on the geometry. This editor here is kind of like if you use Maya or other node-based kind of like shader editors. That's kind of what you can do here, just quick ways to change the color. I could put the position coordinate into the color vector, then we could see that that's getting applied to the geometry. But I could also do a noise, so you have this curl noise, and if I put that into the color, you can see we're getting like a noisy color for each channel, X, Y, and Z, or R, G, and B. We're getting kind of random values. But instead of putting that into the color, I could put that into the up vector. So we just have these like starting or default outputs that we can use, but then if we want to write or edit or assign values to other attributes that aren't included in this list, you could use a bind. So in this case, it would be the up attribute, and then I would want it to be a 3 float vector or vector, either of these, they're kind of all the same thing. So if I plug that in, now you can see that it's picking that up. Not only in this details view is the, might have to go up here. All right, so not only is it changing here, but it's also changing in the display. So this is an interesting way here. We could use different types of noises and get different noises applied to our up. So the main difference here is like instead of this random, this is like if you dropped a bunch of little things on a table, they would all just get random, they would land in random directions, or they would kind of rotate randomly. But if you want an overall kind of cohesive randomness to things, like in this case, maybe a wind is blowing, might get easier to see with a few more copies. So let's bump that number up. And then I'm just going to make things a little bit smaller. So now you can see that there's like patches of areas that have the same kind of shared direction, like a field of grass with wind or something like that. These would all end up in similar directions. You could even add, if we do this vector to vector 4, this will let you use an additional 4th component. So in this case, our 4th component could be the time. So we have our 3D position, like X, Y, and Z, that's influencing the noise, but then we also have an additional component of time. So when I bring up my time bar, now you can see when I'm playing it, all of these things are changing directions, or the noise is updating over time. So it's almost giving me this effect. I'm just going to turn off this guide geometry. So it turns off those little dots. So over time, our noise is updated. You'd see it's almost like a wind blowing through things, or we have a pretty interesting like animation now. Instead of with this random, we could change the seed, and you just get incoherent kind of results every time. It's a little bit more interesting than just this uniform default or unassigned rotation. And it's useful for certain situations, but then if you want overall like cohesive directions to your rotation, using this curl noise or setting it up this way is a pretty good way to go. So instead of this default axis, we could go to like the default geo. You'd see we're still getting the labels, but now we have boxes. And if I want to change things with this scale, so that our Z direction is up, that's what's kind of the height direction. So if I go to my scale attribute and I start to increase that, then we're just making things taller, but not necessarily wider. So the P scale, that's a uniform scale. So if I make that bigger, you can see all of the directions are getting uniformly scaled. But if I have this scale vector, I have 3 numbers. So if I wanted to, I could make things like really wide in one direction and really skinny in another direction. I could make it like really short too. Or I could make it tall, kind of something like that. So again, just having this ability to control things with such like specificity, this will really help us get our final images set up the way that we want to. So we have our uniform scale, we have our directional scale, and we have the up vector that's telling it which way to rotate things. This is just like if we wanted to assign it. This is if we wanted to do random, and then this one is doing our noises. So another place you would go to refer to things is this website here that's a blog this guy made. His name's Toadstorm, or that's what he is calling his blog. So this is a super kind of good overview to refer to everything that I've gone over. If you don't like kind of jumping around videos to find specific numbers or explanations, this is a super in-depth, like a dictionary or like an instruction manual that you could go to really refer to things. So now you could see that when we're scaling everything, when I'm making it taller, it's going in both directions, like up and down. And that's because this starting box is like already half above and half below the ground plane, or like 0, 0. So if you want to fix that, you can just transform it. And then because we're looking down like the z-axis when we're copying things, we have to keep that in mind. So if I want to move it above the z plane, what I can do is go into my z component here and do vbox 0 to get like the whatever's plugged into my node, and then I can do z underscore min. Let me see, I think I messed something up here. So this needs to be d underscore z min. Then you can see it's going the wrong way. This is a negative number. So if I just add the negative symbol, now this is sitting like above the z plane. And when I look at the copy here, now you can see that everything's like standing on the ground. So if I don't do that, everything's like halfway underneath. And then the last thing that I'm going to do is just add a pack node. So this guy right here will essentially like put the geometry into memory, and then when you copy a bunch of instances of it, it's all sharing that one reference or the one instance of things that's in the memory. So you'd see here I'm just using 5 megabytes of memory when I'm instancing or creating all of these copies. If I don't do that, then I'm up to 37 megabytes. So that's because each of these boxes now are unique copies. All of the points are separate like locations and separate things that I could edit or anything like that. But if I pack them first, that's kind of all of these are just referencing the same box or the same geometry. So it's like instancing in 3D software, it's super powerful. If I make 10 times more copies here, it's going to take a while to scatter and lay out the points. But then you would see I'm still using very little memory, just 50 megabytes now. If I get rid of that pack node, now I'm up to like hundreds of megabytes. So as I'm making more and more copies, that number will kind of keep going up exponentially. So any way we can save memory and optimize things is super useful. So we have a pretty good setup now where we're packing things, we're keeping everything optimized. You can see it's playing pretty quick. If I want to go back and tweak my scale again, I could make everything a little bit smaller. You'd see we're getting almost real-time playback. It's still pretty quick. So we could even switch to this teapot. This one I brought in just to show kind of how flexible this setup is. if I just plug it in, because we're using this node, I just need to make sure we want him rotated to be on the Z direction. So Z should be up. This guy will move it above the Z plane, and then packing will kind of make it into an instance. And then now we have all of these creations, or all of these distributions of that same teapot. All these are like instances. They're super lightweight copies that are all sharing the same kind of source geometry. So using this workflow, it's a super quick way to, in the viewport, it's like our replacement of XGen, what Lee Griggs was doing. This is the Houdini way to kind of very quickly create, manipulate, and edit like just large instances of geometry. So the last thing we might want to do is play around with the color. So if I do just a color node, I could set this to bounding box. So that's just going to make like this rainbow kind of shape over the rainbow coloring of the geometry. So if I go into a render view tab and click render, so this right here is setting up everything we need to do to instance things. I don't need to worry about using shelf tools or changing the workflow at all. But you can see the one thing we're losing is the color attribute, but our direction and orientation and everything like that is coming across okay. So to make sure we're getting the color, all that we need to do is make a material network, and just need to assign a material. So I usually just do this screwdriver wrench, then under materials, industrial, and they have this plastic. So I can just drag it into here to make a shader. And then you can see here this has a checkbox for use packed color. So if I drag it into my render view, I can see it's basically assigning that material to that geometry, whatever I drag and drop it onto. So now you can see it's getting our point color, or the color from the packed geometry, but it's also multiplying it or compositing it onto our base color. So if I just set these numbers to 1, that will basically, now it's only using the packed color. I could turn off these other ones if I wanted to, or anything like that, but now it's basically only using the packed color to influence how the geometry looks. You can see this is like pretty slow because it's just a lot of like math. It's a lot of things for the renderer to calculate when it's trying to shade all of these points. So if I want to render them a little bit quicker, I could make less of them. Probably want to make them a little bit bigger, maybe even a little bit less. All right. So now it's a little bit quicker for it to figure out what we're looking at. The other thing you can do, I'm using this Redshift renderer. So if I go into Redshift settings, under instancing, then they have this instance SOP level pack primitives. So if I turn that on, and then if I go into my out network, by default it was just making a mantra renderer. But if I specifically create this Redshift render node, then I can switch it here, and now you can see it's super fast to to render the geometry and display it, because it's always just using the GPU to display things. So if I go back into my material network, this material only works with Mantra or the Houdini renderer, but I can make a Redshift, I think it's just this, starts with RS, material builder. I think I can assign it. It doesn't work anymore with the Redshift renderer to drag and drop into the Redshift IPR view, but I think I can drag it here onto the viewport and it will still know what to do with it. So if I go to my geometry, now you can see it's actually getting that Redshift material. So building the Redshift materials, usually just this node, it's a little redundant, but it's called Redshift material. Plug it into color, and we could start again with this plastic. So now you can see it's changing the way things look a little bit. If I want to make it a little bit more rough, maybe this plastic is like a little bit too shiny to start with. So I could increase that roughness. And then to get the color attribute, we want to do this RS point attribute. And then by default, it's looking for this UV tangents attribute. But if I just change it to CD, then that will get that color attribute from the geometry. So Houdini is always using this CD. This stands for color diffuse. That's always just like the surface color. So I can plug it in there, do another render. Now you can see that the Redshift renderer is getting that color attribute from the geometry. So things still look pretty boring. The scene is still pretty simple. So if I starting to make something kind of interesting, maybe I want to move the camera around a little bit, actually create a camera. So I'm just going to control click on that camera shelf tool. That will make a camera from the current view. I switched it to these, you just show these as text, so it saves a little bit of screen space. Then if I want to make a ground plane, I can make a grid, make that pretty big. So now you see we have like ground underneath the geometry. But the lighting is still pretty boring. So it's just making a light from the camera and using that to illuminate the geometry, because we don't have any lights in our scene right now. So I could go ahead. What I actually want to do is go into my Redshift shelf tools. So instead of the default Houdini lights, Redshift has its own lights that it likes to use. So I could make, just click on RS light. So I could move it around here. If I control clicked on that, I could have made a light from my current camera or my current viewport orientation. I could also, I think, just press enter, and that will make it at the origin, or 0, 0, 0. So this could be kind of interesting if we just have like all these guys around a single light source. So I'll just kind of leave it close to the origin. I'll just move it up a little bit. You can see everything is just going in one direction. So that's because I have this, it's an area light, and it's making a rectangle. If I change it to a sphere, now you can see that it's going in all directions. So the rectangle's directional light, I think I could change it somewhere to be bidirectional. You still have this shadow. So if you move away from rectangle and you go to sphere, then you have kind of like a 3D light source. Maybe I'll also just turn off the visibility of it and make it a little bit higher, and under the intensity, I'm just going to make it less bright. So the other thing now that's making it not as interesting is that on our render, settings for Redshift, we're not doing any global illumination. So if I turn on brute force GI, now you can see we're getting like some color bleeding. So that's a pretty cool way to make things look a little bit more realistic. And then I'm just going to go back into my geometry. Maybe we'll go back to the teapots. And just going to make sure here. Sometimes the Redshift renderer, I think the normals on my geometry are getting messed up. So when you copy things to points, it's not only just inheriting the color, but it's also inheriting all of the point attributes. So I'm going to get rid of everything. So you can turn it off, or you can just specifically use this list here. And then I can say only set the colors of my geometry. So this is a pretty nice way. Instead of copying all of these attributes, now I just have position and color. If we go back to something like it was doing with the star, then you can see I'm overwriting, or I'm explicitly setting color, normal, position, p-scale, scale up, all from the template or the instance points. If I get rid of that and just go to CD, go back to render. So I'm trying to get some shadows happening. So it's possible we go through and see if other things might be messed up. So under my light, I'm just going to make it smaller. And then I'm going to go back to having it brighter. So now you can see I'm starting to get some shadows. So this is going to make things a little bit more interesting. Now I'm also, I think this is fine for right now. So I'll go back into my instancing setup. I'm going to go into my scene view and just simplify things for a little bit. I'm going to turn off the rest of the scene, just go to default lighting and turn off materials for now. So make this a lot more points. And then go back to visualizing things. So you'd see this is starting to not display all of the geometry. So like I have too many instances right now. It's just getting a little bit overwhelmed, or it doesn't want to put all of those in the viewport. So if I go to this more simplified shape, it will, the viewport can display all of them. I could also just do a box, and then that will be even quicker for the viewport to display. So we have so many of them, we're going to make them a little bit smaller overall again. And maybe I'll get rid of my random rotations for right now. And I'll just do another VOP that will be modifying this scale. So I'm going to make a bind export, and this is going to be the scale. We'll make sure to set it to a vector, and then we'd start with just like the position. You can see that that's giving me like super small results here. So one of the things I could do is like just get the length of the position. So that's giving me the distance. And if I wanted to, I could like remap that with this fit range. So basically what this is going to do is like, as things are getting closer, further from the origin, it's going to change the scale of the geometry. I think I want to make sure that so this was messing things up a little bit. Um, when you connect like a float value or the wrong data type or the wrong color, it will like overwrite it, or will think that you're trying to make this variable a different, the attribute a different data type. So without that, it's making my scale into a float vector, not a float, sorry, just a float. And it's basically messing everything up. So if I get rid of that there, now you could see it's working a little bit more as expected. So if I change these ranges, now I can start to get some more interesting settings. What I could do is have things like pretty big when it's close to the origin, or just close to 0. And as things get further away, they'll get smaller. But maybe I don't want them to go all the way down to 0, so I'll just do like 0.25. And then this reason here why I was setting things up that way, because I don't want to affect the overall scale in all directions. So I can bring in another scale here, have this just passing through, but then I could multiply it. So if I multiply it, everything's just uniformly like overriding it or affecting each direction. But if I go from float to vector, then I could set like each of these axes independently. So now I could change like y, I could change z. So if I plug that in there, now we have a way to change this, just the height of them, however we want it. So if we go back to my render camera, render view, just see what happens here. Go into my geometry. I'm just going to make this grid a little bit bigger. I'm going to make my copies, maybe this is like 25, the closest number. Ooh, it's pretty big. So go to from 0.1 to 1, and then what I can do is use this power function. So this thing kind of works like a image gamma, like exponential control. So as I boost this exponent, you would see it's like a contrast, or it's like making just these guys here super tall, but the rest of them are a little bit smaller. So this is a good way to have just like, instead of a linear fall off, now it's like an exponential fall off of scale. And then I'm going to change this P scale here to something a little bit bigger. Maybe I'll turn on these random rotations again. Maybe I'll do like even more copies, even more points. And my scale, I'll do 1 for height, 0.1, and 0.1. Maybe we'll do even more copies. So now we're getting like something that could be maybe close to a landscape or close to a lot of points. What I'm going to do now is just make these even bigger so that they start to overlap a little bit, or like stack up. And then I'm going to go back into my camera. I'll lock it so that the viewport is now changing the camera. I'm also going to go into my camera, change the aperture to 36. So this is like a full frame SLR camera when you set this to 36 for aperture. So now my focal lengths would actually correspond to real lenses in real life. Like if I have a 120 millimeter lens, this render would match a 120 millimeter lens that's on a full frame camera. So this is just going to help me get more realistic kind of compositions or settings when I have this at 36. So I'll set it, do another render. Now you can see we're actually getting like something somewhat interesting. Just going to go in here and change this. So I think this Redshift instancing might be this pivot that changes like the origin of things. The other thing sometimes to check is this pack changing the pivot location. Alright, so now it's matching. So I think the Redshift renderer might not sync up 100% with everything. So it's making sure that the pivot location is the origin and not the centroid will keep your viewport and the Redshift renderer kind of like synchronized. And then if we start to look at the edges here, like maybe we want to do a bevel. So this will give us a little bit of rounding or a little bit of detail, or just like kind of like a slope or something like that at the corners. Maybe I'll set this to round, just do like a little one. So now you can see we're getting like actual like shading across our geometry. It isn't just purely flat. One of the things I might want to do is add some more like divisions. So as I'm doing that, you'd see my viewport, my geometry in the viewport disappeared because it was like too much to display, too many points. But in my render view, you can see I'm getting these like smooth corners. It's looking a little bit more realistic now. Everything might be a little bit too shiny, so I'm just going to go into my material, increase the roughness. So when I make my roughness a higher value, that's like a plastic that's less shiny. So all the way at 0, this is like almost like a mirror reflection. And then closer to like 0.5, that might be more of like a Lego brick or something like that that just isn't as shiny. The other thing that changes the like reflectivity is this IOR. So the higher you bring that, the more like reflective things will be across the entire geometry. The lower I bring that, then just like the edges will be shinier. But this starts to look less like a plastic, more of like a paper or something like that. So if I go back up, we'll have some more reflections happening. All right. So if we want this to look more like an actual terrain, one of the things we might want to do is like change the coloring instead of this bounding box. I could do another attribute bop, and this guy will use this bind node to read in attributes. I'll look at this vector. It's going to be the scale. This guy, if I plug it into color, basically what this guy's doing is looking at the scale attribute and changing the color of the geometry based on that. So the X, Y, Z components of my scale are being put into the RGB attribute of the geometry. So instead of looking at all the different components, I might just want to take, do vector to float. So this is like XYZ or RGB. So if I look at just the Z scale, now you can see we just have like kind of like a brightness. So this is the height of our instances. I could do a ramp parameter, and then this will let us make a color ramp for the height. So maybe white is at the top, like it's a snow that's at the higher altitude. As we get a little bit lower, might be maybe like a rock or just dirt or soil or something like that. As we get a little bit lower, maybe it's like green, like some grass or something like that. And at the bottom, maybe black is fine, or like you could even do water or something like that. So this is like how a landscape might work. If I want to change things, I could start kind of like moving my render flag and stuff around. So I might want to render from this one, but I might want to make another copy to points. And then this one is just going to be a simplified version of this geometry. So I'm just holding like Alt and dragging to make copies of these nodes in the node editor. And then this, press T and click on this guy to change the render flag, and then we're displaying the simpler geometry, but we're going to be rendering the smoothed edges or the higher resolution copies of the boxes. I could even add like a subdivide node to make this even higher resolution or even smoother. Then we'll look at this mountain again. One of the things I might want to do here, instead of just taking the length of the geometry and making that like higher at the middle and shorter as things move away, what I could do is add noise to my position. So if I take the position coordinate and use it to generate a noise, add it to the geometry. Whoops. So now you can see that that's moving everything around. It's like a displacement. I might want to make my noise a lower frequency. So we'll multiply the position down before it goes into the noise. Maybe I want the noise to have a bigger amplitude or a bigger displacement. And then right now the noise is, the height is still being driven by just the position before the noise is applied. But maybe I want to apply that fall off after the noise. And then instead of outputting or overriding the position, now I'm just like looking at the input. I'm not affecting the position at all of the points. I'm just adding a noise before this fall off or position is changed. Maybe I want to make this thing a little bit less of a fall off. My exponent might be like a little bit too sharp. So if I decrease that, we'll go back into the camera. I'm going to go back to my grid here and just make this like smaller. So I just want all these points to be like closer to the origin or within the camera view. Now when I look at my preview node, now you can see I'm getting something like closer to a mountain range. We'll just give this a try. These guys are stacking up pretty high right now, but it might still look like pretty cool. So I'm just going to go and lock the camera to my viewport and go in and move it around a little bit. So this Redshift is kind of nice. Everything updates like pretty fast. So setting up a scene, like getting a good composition, nice lighting, nice arrangement, everything like that is pretty quick to set up. You'd see when I was changing stuff with Mantra at the start, it would take a lot longer to actually see what kind of results I was getting. So I'm just going to go in maybe an even higher view, like it's like a helicopter or something like that, taking a photograph of this terrain. Go in, I'm just going to name this ground, so I kind of keep confusing myself here. We'll go into the geo here. I'm going to change this scale, maybe P scale. I'm just going to do scale, make this stuff even thinner. So this is kind of like just giving us more detail or more resolution, because all these guys aren't overlapping as much. If we want even more of them, we can make this number even higher. The nice thing about using a noise like that is that it will just kind of keep giving you more and more detail or more and more resolution as you add more points. So it's taking a while to do the relaxation phase, make sure that the points are like evenly spread out. So I'll just give this a little bit more time. If you want, you could reduce the relax iterations. That will make it a little bit like quicker to give you results, but the points won't be laid out as like evenly or nicely distributed. So the points got laid out. Everything else happens. I'll just do another render. So the camera is still locked to the viewport. Maybe I want to move it around, zoom in a little bit. So it looks like stuff's starting to slow down a little bit with all of these instances or all this stuff going on. I think the other thing that happens with Redshift or with any renderer when you're doing this color that's applied to the point attribute, and then it's getting fed into the renderer, I think what's happening is that it has to make a unique instance of the shader at render time. So that makes updating the renderer pretty slow or pretty painful when you have a lot of points. So I'm just going to cancel my renderer. So basically what I'm talking about is like the step that reads the point color and uses it in the shader is pretty slow. That kind of causes the render to hang. If I really want to, looks like I'm kind of stuck right now. So if I really want to like bail out of this, there's this command that I could filter it just by Houdini. And I'm getting all of the Houdini processes. So if I wanted to kill Houdini, I could have done it that way, but it looks like I got control back. So inside of this material, this attribute lookup is causing like a unique shader to be created for every single color value or every single instance at render time, which is slowing down the scene kind of considerably. So if I just want to like optimize things or change my lighting, change my layout without having everything happen super slow, disabling that point color lookup will speed things up quite a bit. So now you can see I'm like moving things around, everything's updating a lot more quickly or almost interactively. The other thing that I can do to speed that up is if I make a volume. This volume, I'm just going to disconnect my camera for a little bit. This volume node will let you create a volume from a camera. And when you do that, the volume will get the dimensions of the camera view, or something that's called the frustum. So this is making a volume of everything that's like visible by the camera or inside of the camera's window. So if I do volume bound, that will convert from a volume to just like bounding geometry, or actual polygons that are like encapsulating everything within the camera's view. Then I can use a group node, and this guy will be useful because it will let me group. I'm going to set it to points, and instead of like everything by default in my base group, what I can do is bounding regions, and then use this bounding object from the second input. So if I go back to show all objects, now you can see what's happening is I'm grouping only the points that are visible by the camera or within the camera's view. So what I can do now is do a blast node using that group. Instead of deleting points that are visible by the camera, what I can do is delete the points that aren't visible by the camera. Then there's a little bit of control I have here if I wanted to add some more padding. Do a negative number to expand the camera view in each direction. And then this will have to go like higher than 1. So if I subtract this number, it will like just expand in the positive x direction. Then if I want to, I could just copy this and paste it again. So now I'll have a little bit of padding or margins or something like that to work with. But you can see rendering everything should be a little bit quicker now. But we're getting this visible cropping that's happening at the bottom. So maybe just this bottom number, want to expand -y, or what's below the screen, to make sure that that doesn't happen. So now you can see we're getting everything again. All right, so go back to this scale, like the uniform or the non-uniform scales. I can make this even smaller. So I'm trying to get even more detail or less like overlapping. Looks like this guy's a little bit too skinny now. So I'll just go up a little bit more. I'm just going to link these parameters so I don't have to keep updating them. It's a little tedious to keep putting the same number in both of them. So this is starting to feel a little bit better. I'm just going to go back and tweak my noise a little bit. I'm going to change my display back to the full height. So if I get rid of this high number for roughness, you'd see I'm getting like a little bit smoother of a mountain. See if I tie my camera back to the view, keep it updating, like it still keeps cropping everything procedurally, which is pretty useful optimization to have. Maybe my noise, I want it like a higher frequency, and maybe I want it like super distorted. Now I'm starting to get some pretty cool kind of elevation. So I'm just going to go here, increase my width, just the X and Y scale components, trying to get a little bit more overlap. I'm trying to get rid of like these like stepping kind of areas. So another way that I can do that is just make the roughness of the noise higher. Maybe not that high. So I'm just trying to get a little bit more breakup in those areas. Let me think. So another thing, this is kind of an advanced move. But another thing that I can do, so unfortunately when you change the input, like your noise will also change. So my 3D offset changes to a 4D offset when I update this. So I could like paste these numbers. Oh, okay, so this is also changing to a 1D noise. So now if I go back to the 3D noise, now I'm getting something similar to what I was before. What I'm going to do is just generate a random number from my point number and put that into the final component. And can change the frequency a little bit. So if I just have a lower frequency, this is basically just going to add some like incoherent randomness to each copy. So that's going to be another useful way to kind of break up that stepping or just that banding kind of stuff that I was talking about. This is pretty cool. I'm starting to get something somewhat interesting. We'll just go back now, and if I wanted to have some more control over everything overall, one thing I could do is like clamp the scales. So this wrangle node works the same way that these VOPs do, but instead of making nodes to which generate code, this one will just kind of create the code directly. So if you look inside of it, it's still a VOP that's changing things, but this is just a different way to edit or control the code. So I'm going to look at the scale, this vector scale, but just the Z component. So you do .z, and that's like our height. So if I take this, then I can do a clamp function. I can set like the minimum and maximum of my scale, or the height of my copies. So we'll do 0 and 0.25. So you can see that's just like creating a flat plateau at the top of everything. So that's another kind of useful like tool or technique that I was using when I was making all of my pictures or the compositions. Maybe this guy's a little bit too short, so I could increase that a little bit more. So this is just like the elevation that we're clamping everything off at. If you look at like some pictures of the Grand Canyon, it's kind of like what happens there. So at a certain elevation, like nothing goes higher than that. It's almost like a straight line. So it's like the clamp function. Everything can't get higher than a certain altitude. That's basically what we're doing with this code. If we want to, we can also do some of that stepping or the terracing. So what I'm talking about here is like you could see there's certain specific bands where everything is plateauing off, but then it goes higher and plateaus off again. Um, so this is called, I believe it's called terracing. You can see what's terrace. Uh, maybe terracing terrain. So this is the kind of stuff that I'm talking about. Plateaus for a little bit, and then it increases in elevation, and then it levels out again. So the way that I can do that is if you do this floor function, what this is going to do is um, take your value and snap it to the lowest nearest integer. So by default, right now, everything is just below 0. So my scale.z, or the height, is all getting assigned 0 when I do this floor. But if I make it higher, like 25, now you can see I'm getting the terracing at each integer. Each number here is snapping to a height of 1, to a height of 2, and so on. And then if I want to go back to my original values, or somewhat close to it, I can just divide back to 25. So what I'm doing is I'm kind of like expanding my number range, clamping it or slamming it down to like the nearest integer, and then normalizing or like returning back to the original number range that I was in. If I want to build this out a little bit more, I could do like terrace, and I could set that to a specific channel or like a user input. And then this guy, I'll just call this terrace again. So I click this button here and it will automatically make like a slider for me. And I could set this number to 12. And then this is another way to kind of like get rid of redundancies or like tedious elements of your code. So basically, this guy will let me set the amount of stepping. So the higher this number gets, the like more and the higher frequency kind of my terracing will happen. So if I just want a few terraces, I set that number lower. And then it looks like it doesn't like these numbers here at the bottom being all the way down at 0. So if I do like another clamp, maybe I want my numbers to be at least a little bit. What I could also do is like this plus equals, that just means add a number, and just add a very small number to my scale. And that's kind of the same thing. So if I go back to my material, I can plug the color in again. So because I did this extra stuff of like setting the crop region and only sending a smaller data set to the renderer, that's going to make it a little bit faster, but you can still see it's still a little bit slow to update the renderer when I have my colors applied. So I'm just going to disconnect that again. I'm going to get rid of this light for right now. This looks a little bit weird. It's like a little retro, like Final Fantasy VII or something like that. So what I'm going to do is use my view to set a camera. This is going to be like a sun position, just the overall position of the light. So if I control click, then it will make a light from where my viewport was set. If I do this pipe keyboard shortcut, just like the vertical bar, then that will return my viewport to the camera. So I could drag this into the viewport again if and lock it if I want to move things around. If I move it closer, you'll see that these shadows, they become a little less parallel, but the light overall is like more intense because the light source moves closer. So I could also increase the light intensity this way. Maybe I don't want my shadows going in that direction. I could move my light around a little bit to play with different directionality of the light, of the shadows. So we'll go back into the geo here, and I'm just going to get rid of the terracing, make it less noticeable. So now we have like 35 high frequency kind of like terracing happening. What we could also do is like maybe this terracing is only happening above a certain altitude. So I could do like if scale.z, where the height is greater than 0.2, then do this terracing. So if I go into my camera, if I change this to just greater than 0, which is everything, looks the same. Let's go greater than 3. I don't know. This seems a little funny. Oh, okay. So this shouldn't have a colon after it. That's just an improper way to set up this if statement. When you just have one thing happening after it, you can leave it blank, or you could also do these brackets to basically tell the compiler, the code, tell Houdini, just execute this one line of code if the condition is true. So if I go back to 0, now everything above 0 will get the terracing applied to it. If I set that to 0.25, now just things above 0.25 will get this terracing applied to it. So this kind of gives us even more control over things. So the reason I did that is because you still want to see like a lot of detail at the ground level of the terrain, but as things get higher, then you expect like the terracing to kind of happen. So that is something that is generally true. Like these are specific things I think these people did to farm stuff, but usually with rock formations, especially canyons and stuff like that, I don't know. I think these are all computer generated, so they're not necessarily realistic. I don't know. Give up on these. This one's pretty nice here. Give up on this reference stuff for now. So we're getting pretty close to like, I don't know, something that looks useful or would be cool to render. So we'll just kind of finish this up. With our camera, with Redshift, I like to use this depth of field. So this will give us like things that are in and out of focus, and that's based off of the Houdini camera focus and f-stop. So under sampling, f-stop is like the size of the aperture. You make it smaller, and the aperture gets bigger, or the depth of field gets amplified. then this focal distance is like where the focal plane is. So if I make this number higher, that number is probably too high, maybe just 6. Now you can see I'm getting closer to just like the middle of my image or my composition. So go up maybe a little bit too much. This guy came in. Yeah, so this tutorial, this stream I was doing is all that Lee Griggs inspired stuff. This camera handle, yeah, I was trying that a little bit. I don't know why I wasn't using that in the past, I think. So this was the Lee Griggs stuff that I was going over. But yeah, it's definitely super, super awesome. And it's kind of where I was like using it as a starting point for all this stuff that I was making. So this camera stuff is like, you're talking about if you press the Z button, then you, I don't know, I've always had a tricky time, like, maybe, so if I go out of like the camera view, okay, yeah, so you press the Z hotkey, and that will like toggle you. I don't know, somehow I lost it. Can't get back to my, okay, so you do just Z and O or whatever, and you'll toggle between the two. I was always setting numbers, but yeah, both of those ways are pretty useful. So let's go back to get this middle of the composition or somewhere close to it back in focus. So this is super shallow, like depth of field. I'm just going to go up to smaller aperture or a larger f-stop number. They kind of work like inversely. The bigger your f-stop, the smaller the aperture and the more stuff will be in focus. So if we're playing this like it's a anamorphic camera, you could change the aspect of the bokeh. I'm not exactly sure the correct pronunciation. So now you can see we're starting to get like some squeezing that's happening. So that's kind of like a nice cinematic thing you can do. They also have this power setting. So that is like the contrast of the bokeh. Basically what it's doing is like the outer ring of things that are out of focus. Let me get some references here. So the anamorphic is what I was talking about, where these guys get squeezed. Basically, you photograph things through a lens that's applying distortion to the image. That's like how they filmed older movies to basically start the widescreen format, to shoot stuff in a wider aspect ratio. So things that are further out of focus still retain this lens squeeze when you shoot things with these special lenses. So the power that I was talking about is like basically this outer ring of the bokeh will be sharper the higher that power gets set at. The lower value that you give that number, kind of the flatter these things will be, or the blurrier that they'll be overall. So this is just another way to control things that are in and out of focus. So you'd see here with the power quite high, we're getting like these visible rings. I'll just make a snapshot. I'll just go down to like 0.75. And now it's like a little bit blurrier, or it's going to be like overall just a little bit more creamy. with the things that are out of focus. So it's just some super specific or like things you might want to do if you're really trying to dial in the bokehs. I'm just going to go back into the material and reconnect these colors. So what I was saying earlier is like when you're applying the point color to a shader and instancing geometry, I think all renderers, they still have to make a bunch of unique shaders for each like value, so that will make things a little bit slower. That's why I was tending to disconnect it sometimes. So just make this roughness a little bit lower, just to try to get some more highlights, some more like contrast overall. What I could also do is make my light source lower, so that should give me some longer shadows or just more contrast kind of overall in the image. Maybe I want this more intense or just a brighter light overall. So it's still taking some time to update things. Might be a little bit too bright. I could also just go into my render thing and change the exposure after the fact if I want to that way. So just update it. Now if I go back into my like instancing setup, I could change this. Maybe I don't really want it like water, but more of like a dirt soil or something like that. I could change it that way. So if I have really specific values I want to use to color my my terrain or my geometry, I can set it up this way. I'm just going to make a copy of this and leave it at the side. Another way that I can color my instances or my boxes, instead of this ramp, this is kind of an advanced move, but you can do a texture. So instead of using like UVs or positions, so if I do like relative to bounding box, and then because I'm going from like X and Z coordinates to U and V, you could just do this swizzle vector. This is kind of like a shuffle or something like that. So what I could do is like project an image texture onto the terrain. That might be a cool thing to do, but you can also just even get more fancy with it. So if I take, I'm just going to get rid of this swizzle for now and separate things out. So this is like a visualization of what the swizzle was doing. Basically, I'm taking my X component and putting it into the U, like UV, and then the Z was being used as the V. So this is like the swizzle. But the reason I was splitting it out here is like I could add the height to one of my UV coordinates. So you can see now I'm just getting like distortion only in that area. So it's a pretty cool kind of thing to play around with. I could do that just to one texture coordinate, or I could do that to both the U and the V values, and then you start to get like an abstract thing. So by default, this is like the same thing with the geometry. The texture looks in specific places. Usually these like HFS paths. If you go up a few directories, you see some images. So I was also setting things up here, I had some textures in a folder that I brought with me. So these are like the Lee Griggs kind of things that he was using. So if I get rid of my additions here, you can see this is just like projecting that color values or the paint strokes onto the blocks or the points for the instances. Yeah, so the HFS is the Houdini install directory. I think it's like Houdini file system. So if you get rid of that, expand it, that's just like wherever you've installed Houdini. Is this Bob Ross? Is it? I haven't seen this. I'm not too familiar with the emotes. So now I could render it again with this more of like an alien or an abstract terrain. This was like more inspired somewhat by Lee Griggs with using that ink texture, the like paint mixing texture. But then this is like the G-Monk, kind of like Iceland stuff that I was talking about, where it's like super vibrant, super like alien or abstract kind of landscapes, and just like a two-tone or something like that. Yeah, so this is like a pretty nice hack. It's like the tier 1 strategy. You get, instead of making ramps and like redialing in textures and stuff and the ramp keys and everything like that, you just grab like a texture map. And I think whenever I try to update the Redshift without turning it off and on again with the IPR here, it gets messed up. But yeah, this is a super nice way of just going in, getting some nice abstract kind of like colors, super alien or weird kind of colors, but just trying out different things. It's a quick way to just like pull random values and get something that looks somewhat interesting as a starting point. So if I get rid of these additions, you can see what's happening. It's just like a straight top-down projection, but then this is adding the height of my terrain. So it is an overall distortion just based on elevation. Go back to this one here. Yeah, so this is for sure a Pog Champ move. So a tier 1 strategy. So super realistic or just super nice kind of thing from a starting point. And then so this texture map was the one that I had actually ended up using for these renders here. And then you can see this is how I'm getting that banding, is because the elevation is getting used to distort like the image UVs. Then you get some nice kind of like very rock, natural kind of like formations of these bands. So this is like the starting tool set that's kind of gotten built out. What I'm going to do is just save this now into that same folder. This will be the starting scene demo. So I just wanted to show like building this stuff from scratch, the thought process behind these different workflows or tools or stuff like that I was using. One last thing I wanted to add is like one thing that might be useful is instead of like scattering these points and waiting for the Houdini to like make them all kind of equidistant for the edge lengths or the distances, if you do a remesh on the grid, sometimes this is a faster way to make like a even distribution of points. So works a little bit differently, like instead of setting the overall number, this guy will just choose the point separation. And then if you want to, you could do an add node, the add sop, and then delete all the primitives or the geometry, but just keep only the points. This one also has relax iterations or refinement iterations that you can add. So these are both ways that you could, depending on what you're trying to do, that you can like distribute points evenly. This guy also, you can give it attributes. So like certain points could be more spread out in different areas than others. So that would be a pretty fun thing to kind of explore or try out. So I don't know, sometimes in my tests like this, remesh was faster to make a ton of points but still have them pretty regularly spaced. Sometimes with this scatter node, when I was doing like millions of points, it was starting to get pretty slow. It would take like 10 or 20 minutes just to make a point distribution. So I don't know if maybe it's like not multi-threaded, or this processor should be pretty good, so it shouldn't, I don't know, maybe it's something that doesn't multi-thread that well, but maybe in your circumstance it will work better scattering them than this remesh. So try to let this finish. We'll see how long it takes. Then I'm gonna move into like this actual scene file here and go through it. So hopefully like building things from scratch this way, you can see the thought process behind things. I like to do that instead of just like opening a file that's already done. Then it's harder to kind of like put yourself in the mindset of making that file. This image, oh, the render, I think it's, this is like 9K, or almost like 10K wide. So I wanted the ability to like crop in and do different compositions or whatever. And then I also was like thinking about printing some of these out eventually. So like being able to do 300 DPI, and then with using Redshift render, it was all pretty fast to render. So it looks like my distribution here got finished. But yeah, with Redshift being so fast, you would still do like GI and crazy high resolutions, and it wasn't taking that long. So I was also using, I have HQ or whatever set up on this machine, so I could put them to render in the background or on different computers with it. This is a PogChamp move for sure. So again, because I increased the overall number of points, it just takes a little bit longer for Redshift to build the scene with all these different shaders. But for the actual rendering, like, it's still pretty quick. So if I go in here, maybe I want more bounces. So every time I change one of these settings, you can see it has to rebuild like all those shaders because I'm overriding the color, so it will take a little bit of time. But I might want to, maybe I'll turn this off and then I'll increase my max samples. Sometimes this thing it's like a little bit messed up or whatever. I don't know if it thinks I'm still rendering something, but it's one like frustrating aspect of Redshift is, even though this is off, I think it's still trying to render more like IPR images. So I was just trying to kind of show you guys what a final render resolution or render like noise settings might be. So sometimes I have to like start another renderer and then stop it to make sure that it's stopped. Looks like it's still bugging out on me a little bit. So I was just show you guys how it was, if you run into this situation where like Redshift's hanging your Houdini scene, if you're doing Mac or Linux, you would do this kill.segv command, and then you can grab your process, and then that should kind of make Houdini dump like a crash file. So now if I go just do a new Houdini file, usually I'll do this -n flag to make sure it opens in manual mode, and then paste that crash file in, and you're kind of back in action. It's a pretty quick way to just like flush everything out or whatever is hanging. Unfortunately, we'd have to wait for this relaxation like iterations, and it would take a while. So I'll just save this guy, go back into this folder, just make it version 2. Then I'm going to open the like actual live demo. So this is going to be this image that I was doing here. Get out of manual mode. So you'd see overall I've still set things up in a pretty similar skeleton or network or whatever. We have the geometry that's getting instanced onto the points. It's just a box moving it above the z-axis, beveling the edges to get some rounding, subdividing, adding the normals. I think Redshift likes when the geometry it's rendering has normals. With Houdini or the Mantra one, it will like automatically calculate it. But yeah, so when I was making this project, I knew that it was going to be one I wanted to go over for Twitch or for tutorials. So I tried to like spend a lot of time just thinking the simplest way to create this. So like a lot of times you'll be working, you'll just make this huge file that's a mess, and you never want to look at it again, but I knew this was going to be something I kind of wanted to refer back to. So then also just usually with Houdini, I'll try to work almost like a minimal kind of workflow, or just if you can do something with a single node, it's a lot cleaner, it's a lot easier to follow than using like 200 nodes and for loops and subnets and stuff like that. So the other thing that I was doing was I have this node here that will visualize the Z depth of the camera. So when I was setting things like the focal plane, this was a pretty useful thing that I was doing. So instead of like waiting for a render to launch and then see where your focal plane is or what's in focus or what's out of focus, this node will basically transform your geometry into the camera space or into the I guess like the camera space. So you get the camera matrix, then you invert it and multiply your position by it. And then your distance is like -z. You could subtract your focal distance from that and do the absolute value. And then anything that is black is like right on the focal plane, and things get brighter as they move away. So you could do it that way. I was also linking like my camera depth parameter to this node, and then I could like pause a render and get a super fast interactive way of like setting the focal plane. Yeah, you could. I didn't take the time to figure out like the math behind it, but I don't know if it would be like a linear multiplication or if it would be like an exponential thing to do the f-stop. But that would be a super cool thing to add. You could also even like extend this and have this modifying the geometry. So like things that are close to the focal plane could get really like high fidelity, like small scale, high resolution, and then as things get away from the focal plane, it could like get a lower resolution. That'd be pretty cool. But yeah, this is pretty straightforward. The lighting, let me just get this thing here. So the lighting, I was doing it a similar way. I just have a light that's pretty far away, kind of like a sun or a distant light or something like that. Then the grid, the same stuff is getting done at the bottom. Building a camera frustum, using the volume node and then cropping the points just to keep what's within the camera display with some padding. So I could move my display flag to the camera, or to that copy node. Material, everything was pretty much the same. Doing plastic with some roughness, getting the point color, and with Redshift, just make sure that you have the instance stop level pack primitives on when you're rendering them. So this camera resolution, like I could multiply this by 2 to get up to that like super high 10K resolution or whatever. We could do a render and see. Should come pretty quickly. So it looks like it's still building the scene, computing things. So that's pretty quick to render super high, at least loaded into the renderer. It takes a while to like refine and get the noise resolved and stuff like that. But even for interactive like lighting and just getting a sense of how things are laid out, it's pretty quick. And then this is that final image. I think when I was cleaning up the file, things might look a little bit different, but overall the noise and colors and shapes and everything like that are broadly the same. So this file will be part of like the little package that I'll distribute after the stream, so you guys can play around with it. I don't know if we have a few people in here right now. Did anyone have any questions kind of about this workflow or anything overall? So I'll go through and I'll make a copy of this camera, and then I'll just kind of feel free to interrupt me or to ask any questions, but I'm just going to spend some time here showing how easy it is with like coming up with new compositions or finding new areas of the terrain with this stuff getting like cropped out and moving around. Yeah, so I think the startup time, I don't know, it takes like 2 minutes or 3 minutes for the renderer to load everything. So I think that was just like with all the instances, with Redshift using the color attribute of the packed geometry, or I think any renderer that does it, like even with Mantra, I was having the same problem. Under the hood, it has to make basically like a unique instance or unique copy of the shader, or just like building whatever the RS scene or the rib file or the scene description just gets kind of slow with all the different colors or like variations of the shader. So one thing that I was doing was just disconnecting the color override on the shader, and then I found that like made just like the initial render a lot quicker. So when you're laying out the camera or like changing lighting or stuff like that, it might be a little bit easier to just set up everything. You could still have the color in the viewport, but with Redshift or even Mantra or whatever renderer you're using, just do a black and white kind of like lighting or shading or something like that. I also like at some point I just did a render with a constant shader with the colors, and then I like Redshift, I was projecting the colors onto the geometry, but that just seemed like a mess to like pursue or to go down that path. So I kind of gave up on that. But yeah, this is a pretty good workflow, pretty fun kind of approach that I was finding to play around with all this stuff, just like super fast, um, pretty interactive, and moving everything around. There wasn't subsurface scattering in any of the renders that I ended up. So the final project was on this. So I'm starting to make like a Behance profile or whatever. Um, None of these renders had subsurface scattering. It was something that I had played around with, but it just seemed like it caused like too much kind of contrast in the image, or it was just like you stopped kind of being able to read the the uh, the overall shapes. So this one is not subsurface; it's just that super bouncy kind of like indirect diffuse with Redshift. So I was always making the indirect lighting like the I don't know like 20 diffuse bounces or something like that. So so yeah, it's basically that's like how I was getting all that bleeding or whatever. Um, there was one render I think I had with like when I was developing everything that try to pull it up here. Um, where I was playing around with the subsurface. Yeah, the GPU wasn't happy with that. Um, so these were just like different tests and stuff like that. I think it's trying to cache all the images. Um, so I was just like made a bunch and then culled it down quite a bit to get to the ones that I was sharing on Behance. So all these are just like throwaway ones or different work in progress things or something like that. Just kind of, they all ended up on maybe the cutting room floor. But there was there was a specific landscape where there was one where I was really trying the subsurface stuff a little bit, but it just didn't turn out to be something that was helping that much with like the final image. I don't know if I'll be able to find it. So this might be too many images that I'm trying to cache right here. Yeah, I don't know if I'll be able to find it. It was like a blue landscape. It might have been. Okay, yeah, I think it's in this area. So I think it was these right here. You could start to see like a little bit of subsurface or a little bit of like penetration of the light into these. But yeah, 'cause I figured this was like a glacier or like something like that. But I don't know. Overall, I felt like it was just making like these broader shapes harder to read. It was kind of just like blurring the overall image, so that approach with just like super high bounce light was something that I thought was just a little bit more successful overall or whatever. But yeah, so this was the overall approach, like just moving things around in the 3D scene, working on the lighting, and then eventually like turning that color back on, and then I was using, like I said, this HQ render, so I could just once I found like a composition and stuff that I liked, could just like make a copy of my scene. Usually I was just like versioning things up and then submit it. Then get a new HQ here. So I have a couple machines running. It looked like this one picked up on the actual machine that I'm using. So you'd see it happening like in the activity monitor a little bit. But then this render would just go out in the background. It might take an hour or two or something like that for like one of these 10K images. But I had my noise thresholds pretty low, so I was trying to get all the noise out of the shadows, and then the out of focus areas I think made it take a little bit longer. This HQ, I don't know, like I think it's pretty useful for just like a personal workstation. I was gonna try what is the deadline one, but I had to install all these other like dependencies. It was, yeah, so I was just gonna have like the 2 licenses for free with it. So I figured if I wanted to expand stuff, this HQ was a little bit better. And then all the dependencies with Deadline, like installing the node, all those packages and stuff, it didn't seem to like my Linux that much when I was trying it. This HQ seems pretty fast, and then also using like trying out some of the top networks, and then using all of those on the HQ render farm, maybe it might be a little bit easier. But yeah, so I'll be posting these files that I was going over, like the tool set file, the like fresh scene or empty scene file, and then this one right here. I'll be kind of packaging them up and putting them online. I'll put the link like in the chat, or if you're looking at the VOD, the recording or whatever, you'll probably be able to find out where that link is. So if nobody has any questions, this is probably going to be the end of this stream. I'll give you guys a chance to chime in. If not, yeah, thanks for coming by. Tell more people about this. Hopefully we'll slowly build more of a community here on Twitch, and I really like the way that this chat works. And like, I don't know, maybe at some point people could bring in their files or their stuff that they're working on and share it, and we could go over it like as a group or something like that. But yeah, looking forward to seeing where things go. Yeah, so I didn't really figure out an entire schedule. It probably won't be next Sunday because I think that's like the Super Bowl or whatever. I'm hoping to do like some larger overall sessions that are like this kind of more in-depth lectures almost, and then something that's more closer to like an office hours or like Q&A period that's maybe me just messing around, or if you guys have specific questions, or if anyone wants to share anything or something like that. So maybe like twice a week, one lecture like this and one more of just like free-form messing around stuff, but still figuring everything out, still kind of seeing what happens. So kind of, if you guys have specific feedback or critiques on how this stream went, on Twitter I think is going to be the easiest way to figure this out, or share and communicate with me like offline or off stream. But yeah, this is my Twitter, just at KoonsXL, extra large, extra tall. So feel free to send me a tweet or something like that if you have any future recommendations, stuff you want to see me go over, critiques or issues finding anything. So probably get the link going in a tweet. But yeah, other than that, I hope you guys enjoy the rest of your weekend. Yeah, I still need to go through my Twitch profile and add the banners and like contact and stuff like that. I'm still figuring this out. Hopefully in the future these streams will be a little bit more professional, a little bit more concise, and less scuffed in general. But yeah, thanks for coming by, hanging out. Hope you guys enjoy the rest of your day.